Morning. Okay, so this is the handout that you guys picked up yesterday, worksheet 5. Okay, function is defined on the closed interval from -7 to 5. H is the function defined by h prime equals f of x. So basically, this is the h prime graph. Okay. And we do have a anchor point here. H of -2 equals 3. So part A, find h of 0. So we don't have an explicit formula that tells us what the integral is, so we have to kind of build it ourselves. We know it's going to have to be our anchor point plus displacement. So let me write that formula that we're going to be using here. Okay, so I want to find h of 0. That's my endpoint. That's my basically my b value. And then my initial point is at -2. I need to bridge that gap between my starting and end point. H of -2 is 3. And then from -2 to 0, it's going to be this area of a triangle that we see there. Go ahead and find the area associated with that. That's 1/2 base times height below the x-axis. Oops, sorry, -2 to 0, not from negative. So I don't need this just yet, just from -2 to 0 here. So if I want to think about just this region here, that's a quarter circle. We know that pi r squared is circle. Quarter circle will be 1/4 pi r squared. My radius is 2. So 4 over 4 is just 1. So this is just pi here. I know this must be pi as well. So the region from -2 to 0 will just be pi. It's around 6 point something, 6.14. H prime of 0. Definition says that h prime is f, so h prime is 0, which is f of 0. This is the f graph, so just looking for the order pair. And f of 0 is just at this point here. H double prime is just asking for the derivative of f. F is f prime. F prime is the slope of this f graph. So the slope of f graph at 0, this is basically just the slope 0, right? Horizontal tangent line here. Okay, any questions with part A? Okay, right. So it depends on what's given to you. If what's given to me is from negative 7, then I need to figure out from negative 7 all the way to 0. So, but we understand we got to use this formula, right? Okay. So x of b is my target. That's my final location. My initial location is whatever is given to me. So whatever is given to me, I have to start wherever they tell me. So if that's starting at a different point, then that's going to impact my integral here.
And 0 is just
because that's what I'm looking for.
Okay.
Right? Yeah. Yeah. So you're always going to have some sort of information as to what your A and B values are. It'll always be somehow has to be provided in the problem. Your destination and your starting point. Good. Anything else in part A? Part B, between -7 and 5, when is the graph of H both decreasing and concave up at the same time? So this is not the H graph, it's the H prime graph. So we can't just say, oh, this is rising and falling. We have to look at it, understand that we have to adapt this derivative graph here or know how to read it. Okay, so as a reminder, I like to label what I'm looking at here. Above the x-axis means where my original H graph is going to be rising. Below the x-axis is where my original H graph is going to be decreasing. On the x-axis is where slope is 0. Here's my slope sign line. So what critical points can I place onto my sign line? Yeah, x-intercepts. Yeah, -2, 2, and 4.5. Okay, between -7 and -2, what do you see? This is what? Yeah, below the x-axis. The fact that it's rising, that's something else. That's for concavity. Okay. Below the x-axis, so negative. -2 to 2 above the x-axis, that's going to translate to positive. 2 to 4.5 still above the x-axis, so still positive. And then here below the x-axis, negative to the right of 4.5. Okay, so this is how the original graph is going to behave. It's going to look a little different than what we see in our H prime. Okay, H double prime. Concavity sign line. Okay, so where are our points of inflection off of our H prime graph? Points of inflection, peaks and valleys, right? Where do you see peaks and valleys?
0,
0,
2, and 3.
3. Yeah. Between -7 and 0 is concavity is positive because anything that has positive slope, that means if my slope is becoming more positive, my original graph is going to look like a concave up graph. Okay, so positive slope on the H prime graph means concave up. between 0 and 2, we see my H prime graph is falling. Decreasing slope means concave down, then concave up, then concave down. Look at the slopes. So we're looking for a place where we're looking for decreasing and concave up. So arrow down, concave up at the same time. So where do you see that interval happening? Where else? Oh, is that it? Yeah, from -7 to -2, decreasing and concave up. And if you want to look at the graph to tell that, that means you want to look for a place where the graph is below the x-axis, so decreasing, and positive slope. So the only thing that I see is here, right? Only place where it's below the x-axis that's showing positive slope. So our reasoning is h of x is decreasing concave up. On this interval, since h prime is less than 0, f of x graph is below the x-axis, and our slope of h prime is positive, or h double prime is greater than 0. Okay, are you okay? Part B. Part C, let j equals f of x times g of x of 2. Find the equation of the tangent line of j at x equals 4. So tangent line equation, we've seen this before. We need to find order pair and slope. So order pair comes from the original function. So we can plug 4 into all the x's, get the y value. So f is our graph above us. So f of 4, this point here. So f of 4 is just 1. G of 2, we go to our table here. G of 2 equals 5. Are we okay with order pair here? Next up, we need to find the slope to get the slope. We need to find the derivative to get the derivative. We see that there's a need for product rule. And a little bit of what? Yeah, chain rule, right? Function within a function there. Okay, so let's build out our product rule. All right, so derivative of f becomes f prime. G function back to f g prime. So g becomes g prime of x over 2 times what? What's the derivative of x over 2? Yeah, basically just 1/2 x, right? 1/2 x becomes 1/2. Are you okay with product rule and a little bit of chain at the end? Okay, so now replace every x with 4. And then we're pulling either from the graph or from the table. So we get f prime of 4 times g of 2 plus f of 4 times g prime of 2 times 1/2. F prime of 4 is asking for the slope of the f graph at 4. Slope of the f graph at 4, which is going to be this negative slope here. So the slope there is just down 4 over 2. The slope of negative 2. G of 2 is 5. F of 4 is 1. That's the y value. G prime of 2, we just pull from the table. It's negative 2 times 1/2. Clean all that up. That gets us negative 11. We have our ordered pair. We have our slope. Finally, point slope. Right. Any questions on the first page? Second page. Part D, is there a time on the interval from -1 to 6 such that G double prime is equal to 0? We don't have G double prime in front of us, so we can't just read the table and look for a value above G on G double prime below 0 and to the right of or above 0. That would be IVT. That'll be easier, but we don't have that data. But we do have something that's close to G double prime. We have G prime, and we know that G double prime is basically just the slope of G prime. So if I can show that the slope of G prime is equal to 0, then I can guarantee this value. So that's basically application of mean value theorem. So mean value theorem, if I adapt it, it's just G double prime is equal to G prime of B minus G prime of A or B minus A. My A and B value is always going to be referenced, -1 and 6. So I'm just going to put that in the formula there. The slope of my G prime graph between 1 and 6. I'm using my table there. I'm getting 2 minus 2 over 7. That's just 0. So the slope between the endpoints is 0. So I know that there must be a place where the exact steepness on the G prime graph is perfectly 0 or exactly 0. So here's my reasoning for mean value theorem. Since G prime is continuous with brackets and differentiable in the open interval, we know that the slope is equal to 0. There must be a point C on the open interval where G double prime of C is equal to 0. Okay, next up, limit. Anytime we see a limit problem, first things first, we got to plug in, right? We don't want to jump into any conclusion. We don't want to do anything like L'Hopital's rule if we don't know what's going on. So first plug in 2, because if we can get a real number out of this, then we stop, right? There's no need to go any further unless there's a problem. So replace every x with 2. So e to the g of 2 minus e to the 5th all over x minus 2. So g of 2, use the table, it's just 5. E to the 5th minus e to the 5th is 0. 2 minus 2 is also 0. 0 over 0. So now we see a problem. We know that there's a hole in the graph, but the limit does exist. We just have to do some additional work to find it. So now we can do L'Hopital's rule, which is take the derivative of the numerator separately, take the derivative of the denominator, and then reevaluate and hope that it will take us to a real number. So e to the u becomes e to the u times u prime. E to the 5th is a constant that goes to 0. X becomes 1, 2 goes to 0. So now that we have an updated expression, we can reevaluate our limit. And using our table of values, we can see actually gets us down to the real number. So now we can stop. We don't do quotient rule because it's not asking for f prime of 2. If it's asking for the derivative of this expression at 2, then we have to go through quotient rule. But this is just using a derivative process to help us find the limit. You never do quotient rule not with this, unless it's saying, okay, if this says that this is the function and it's asking for the derivative of this function at a point, then you have to go through quotient. But anytime limit is involved and you find the derivative, it's just top and bottom separately. That's L'Hopital's rule. Part F. Part F says find the maximum value of h on the closed interval from -7 to 5. Now, this is the max value of h. That's not asking for the max value of h prime. We can't just look at this and say, okay, that's the highest point, that's the lowest point. We're not looking at the correct graph there. So the graph is not provided for h, but we do have h prime or f of x, and we can use EVT accordingly, right? So EVT says we want to test endpoints as a candidate for max, and then test any relative extrema. In this case, we only need to test relative max because it's not asking for minimum. So testing relative minimum, I mean, you can do it, but it's just unnecessary work, or whatever candidate we choose from relative min has no chance of being a maximum value overall. So we pull the slope sine line that we built before. And then we just pull the values that we want to use. So we know we want to test -7. We want to test 5. And we want to test a relative max. So we want to test 4.5 as well. Start off with -7. I'm going to start with the left endpoint first. Again, I have a target point. I can use h of -2. So I know it's going to be final equals initial plus displacements. I know I'm going to involve the area of each of these regions. I'm going to just spend the time to find the areas of each of these triangles and semicircles or quarter circles. So 1/2 base times height. This is 1/2 5 times 1. Base is 5. The height is 1. Below the x-axis, so -5/2. We have pi and pi here. This is 1/2 pi r squared. Ends up giving us 2 pi. Split that between two equal regions, so pi and pi. Here, triangle, 1/2 base times height. My base is 2.5. My height is 3. So 1/2 2.5 times 3, we get 3.75. This triangle here, 1/2 base times height. Below the x-axis, so -0.25. Okay, so back to what we want to do. We want to find h of -7 first. That's one point that we want to identify. So we know that final is equals initial plus displacements. We know that x of b is equal to x of a plus integral from a to b of x prime. So we can adapt that for our problem. We can say h of -7, that's what we want to look for, equals h of, well, we have a anchor point, h of -2. So I know what h of -2 is. I just have to figure out from -2, where's how much movement is the graph going to show in order for me to get to my destination. So h of -7 equals h of -2 plus, and then however much progress I made between -2 and -7 is going to be the displacement. So now once I have this written down, I realize that I don't want to read the graph from left to right, start from right to left. I prefer to read from left to right. So I'm going to adjust the bounds so that I can go from a smaller, from left, from -7 to -2. So I swap the bounds and I replace the plus with a minus. So the region from -7 to -2, we found from the triangle is -2.5. So 3 minus -2.5 is going to be 5.5. All right. Any questions with how we found h of -7?
So where'd you get -5/2 from?
Oh, I got it from the triangle here. Area of this triangle here, 1/2 base times height. And it's below the x-axis, so negative. Okay, h of 4.5. I'm starting at my target, my initial point or my anchor point, -2. And then I'm bridging the gap between -2 and 4.5. In this case, I don't have to adjust the bounds. It's already from smaller to larger. So just have to read the graph, find the area that's involved here. So that's going to be the quarter circle, or sorry, the quarter circle or the half circle, semicircle plus the triangle, 3.75. So from -2 to 4.5, it's going to be this plus this plus this. Okay, finally, h of 5. H of 5 is h of -2 plus the integral from -2 to 5 of h prime. So that's 3 plus 2 pi plus 3.75 minus 0.25, 12.783. So comparing all these values here, I'm looking for the highest. So the highest I see is 13.033. That's 3 plus 2 pi plus 3.75, or 6.75 plus 2 pi. That's going to be my absolute maximum. I've tested all my candidates. This is the one that is the highest.
How'd you know to use h of -2?
Because that's the point given to me.
Okay.
Yeah, we use whatever point is provided. We're kind of forced into this. This is our only point that we know of on the H of X graph. So that's the point that's going to help us reference to any other point that we want to find. Okay, any questions up to F? Okay, here's part G. We have a definite integral problem. This is a messy integral problem here. We know that we maybe have to go through U substitution, because anytime we have a messy integral problem that we don't have an initial rule for, we know we got to break it down and make it look like a simpler problem. So the way to get to a simpler problem is go through U substitution. So what's our U value? Our U value is typically the portion inside the parentheses. So this could be a good candidate for my U value. And if we think ahead, what's the derivative of G prime gonna give us? G double prime. So that's good, right? We see G double prime waiting for us. So we know that whatever value that we choose for U, if we can see some variation of the derivative waiting for us, then we know that should be a good fit. We should be able to get things to cancel out and clean up in a way that we would like for U substitution. So here's our U value. Okay, so what does G prime of 2x turn into? Mm-hmm. Is that it?
Thanks.
Times what?
2.
Times 2, yeah. So we do outside derivative times inside derivative. So G prime becomes G double prime. We keep the inside intact, and we multiply by the inside derivative. 2x becomes 2. Right, cross multiply and solve for dx, because that's the next piece that we want to replace. Sorry, I copied it wrong. Okay, make our substitution here. Replace this bracket with u. Keep that, and then replace dx with du over 2 g double prime 2x. Okay, our goal is to get everything in terms of u, and we get all the x's to cancel out. Yes. Okay, but there's a leftover we got to keep track of, right? That's our leftover. Yeah, let's pull that in front. So now it's a lot cleaner, right? These are the same problem. We just gotten it to the point where we can actually recognize the rule that we're going to use. And also U substitution allows us to keep track of the fact that, oh, there's going to be a 1/2 that needs to be part of the answer. That's harder to see at this stage, but if we go through U substitution, we can get that piece to show up just by going through our process. Okay, so we're ready for our power rule, right? U squared, the 1/2 is going to stay. U squared, though, becomes what? Okay, so we have our antiderivative, which is basically 1/6 u cubed. And we want to start involving our bounds, but can we involve the bounds at this stage with the u and with the -1 and 3? What's the issue? Yeah, so we want these to be the same variable, right? Most of us prefer to just bring the u back in terms of x, which is what, that's perfectly fine. Replacing u in terms of x and then just plug in the upper and lower bound. Or we can leave this in terms of u, but if we want to leave this in terms of u, we got to change these bounds to be in terms of what? U as well. So you would plug the -1 in here, get the u value, plug the 2 in here, get the u value, and then plug in the upper and lower bounds. Okay, but I think we prefer, I think it's good to know both, how to do both ways, but if it's free response, then you're always going to have a choice. But there's multiple choice on the AP exam. Sometimes they force you into this step. Okay, so u comes back in terms of x. Okay, now we can work in the bounds, -1 and 3. Okay, what do we evaluate first? Yeah, upper bound. Okay, g prime of 6. Use a table. That's just 2. G prime of -2. Use a table as well, which is -3. And then we have 8/6 plus 27/6 ends up giving us 35/6. So 2 replaces g prime. 2 cubed is 8. -3 cubed is -27. I got 2 negatives there, so that's +27.
Just the two replace the G prime 6.
Oh, because we want to get this down to a number. So we want to keep going. So g prime of 6, we can just use our table because g prime of 6, if we can go further, we want to keep going. Now, if we didn't have the table in front of us, then we would be stuck with just leaving our answer like this. But if we have information to get this down to a number, then we keep going.
Why'd you cube your answer again?
Because the cube came from the u cubed here. So when I made the substitution, the cube is still there. Okay, let me pick out some the problems from worksheet 4 that we didn't finish yesterday. Or any other questions that you guys have from worksheet 5?
What was when we did E? Could you do E?
Mm-hmm. Yeah, so E is just L'Hopital's rule. We first start by plugging 2 in for all the x's, and then we see what that leads us. If that gives us a real number, we stop. But in this case, it gets us 0/0, which is indeterminate form. So indeterminate form allows us to use L'Hopital's rule. We can take the derivative of the top and then take the derivative of the bottom separately and then reevaluate, and it gets us down to a real number so we can stop. Okay, page 23. '23 says find the average value of f prime. So average value, that's formula here that we've seen this semester here. So average value is just basically area divided by the width equals the height. Rearranging basically a rectangular area formula. So our A and B values are -2 and 8. I want to find the average value of f prime, so I'm going to make this f prime instead for our problem. So we just replace every A and B with -2 and 8, find the area, take the area divided by the width. Okay. A is -2, B is 8. So 1/8 minus -2 from -2 to 8. This cleans up to be just a number 1/10. -2 to 8 is just the area or the displacements of my f prime graph. So from -2 to 8, I just add up all these numbers here. So 16 minus 4 is 12. And then 12 divided by 10 is just 6/5. Part J here, the wording is similar, but it says find the average rate of change of f prime. So average rate of change of f prime, that's basically asking for the slope. So we just find the slope between the two endpoints on the f prime graph. So slope is just change in f prime over the change in x. So f prime of 8 minus f prime of 1. We do have the f prime graph in front of us, so we just find the order pair. F prime of 8 is -4. That's a point on the graph. F prime of 1 is 2. That's a point on the graph as well. So -4 minus 2 over 8 minus 1 is -6/7. That's my average rate of change. That's my slope. Okay, next up, let P of X equal -2 to 3x of f prime. Find the value of P of 1 and the value of P prime of 1. So P of 1 is easier. We can just plug in and involve the area under the graph. Replace the x with my x that I want to use. So 3 times 1 is just 3. So this is simply asking for the area of the region between -2 and 3. Oops, sorry, it's 3. Now this one is only asking for up to this point here. And that's just this small triangle here. So the width is 1, or base is 1. The height is 2. So 1/2 1 times 2 is just equal to 1. So that little region there is just going to be a small triangle, just 1. So 4 plus 4 plus 1. It's not. Now, if I want to find P prime of 1, I first get the P prime of X. To get the P prime of X, notice that we got to find the derivative of this integral here. So that's kind of reminds us of second theorem, right? So let me remind us of second theorem here. Second theorem says, if I have a derivative and integral notation canceling each other out, my function is not going to change, but my upper bound will have some impact on my answer. So my upper bound will get inserted into the variable of my expression. But I'm not going to change this overall function. It's not going to turn into f prime. It's just going to stay the function. It just has to be plugged in. And the upper bound gets impacted by the derivative process here. So times p prime. So if I want to find p prime of x, that's just the derivative from -2 to 3x of f prime. So if I just use what second theorem tells me, I know these two operations cancel each other out, that f prime is going to largely remain unchanged. I just have to plug my upper bound into my function, my variable. So 3x is plugged into f prime, so f prime of 3x times p prime. What's my upper bound's derivative? That's 3. So now we have a formula. We can now plug one in. F prime of 3, that's just the point on my graph there. So f prime of 3, this is the f prime graph. So f prime of 3 is just going to be equal to 2. Okay, I'll come around, see if you guys have any questions.
So if we look in the cell 60.
E to 0 is e to the first power is itself, and e raised to any of the powers is going to be
Okay, let's go up.
It's 0 to 1 is going to be
Oh, yeah. Those is already on that.
Okay, so this, for this one, is
We're up.
or like you have.
Yes. Actually, I feel like you could do it.
Just there.
I think I like this one.
testing the appropriate candidates.
And also, I can do this one, do the second. Yeah.
It's just yeah. First year in the we don't know.
Like five. Well, it's not study. Just the area to describe.
So basically, when you went about finding,
This one's a certain.
But I'm gonna do it that one.
find out what was that's basically.
So I'm gonna take it out.
Yes,
No,
it's
I'm just gonna buy it. It's very cool.
You use to ship it out.
I'll tell. Oh, okay.
I don't know what I'm gonna
They're just no general, like you say it's continuous and differentiable.
Yeah.
And then, but like, what if I mess up like that? It's asking for G so.
Right,
So
that's
if it's
basically.
asking for G prime, then I would say since of that. And then,
Because we're trying to prove that the slope is equal to 0. So we have to first establish that the function we're working with is 5.
okay,
And then the slope of that function is 0. So therefore, so this is our final conclusion. But this, we don't have that information.
like if this was just G prime,
Then you will say g of x.
and then G,
Yes.
and then,
Or g of x. Yeah, so everything here is going to be 1 degree lower than that.
okay.
I don't know. I thought it was.
All right, and then also, right
Oh,
here.
yes. Yeah.
What is f prime of 4? Cause you got negative, you got -2, and I think it's -1.
Oh. Which
F
one?
prime of 4.
FRQ.
Because like right here is 4 is right here. And then the slope would be
You do A?
-1.
Let's do that one.
Well, this is F, this is F. This is not F prime. So F prime is a slope.
Yeah.
I can
The
just.
slope, isn't the slope -1?
So 1B minus.
If I'm going down 1 unit and over 1/2, it's gonna be -2. Or maybe the safer way to do this, fine, yeah, it's over 1/2, right? Safer way is to just pick these 2 points and then just like. Yeah.
Okay, so, yeah. What do I do? How it's just one.
And this basically works gonna be like this one. Not any of, it won't have like ICTs and stuff like that.
Probably not, but I think if you get page 21 to 23,
Let's
also go.
Just better take this.
But this is like mainly what I need to look at.
Yeah, between worksheet 4 and worksheet 5, those are the best ones.
Okay.
Yeah.
How did you guys this?
I'm just reading what the graph tells me. So H prime of 0. F the Y value. H double prime is just F prime. I point one derivative down here, guys. It's down here. So
That's not this.
F graph is like 0.
That's just
Right.
Well, they're probably like that.
Well, that'll come later. We're on the dash today.
There you go. So now.
Oh,
So then like I was doing this one right here
yeah.
and
Just look at the graph.
for age, and then you did like the U substitution, like U to the 1/3 and I did that. Then somehow you got U to the 4/3 over 4/3.
Yeah, because I did power rule.
That's what that last.
So how do I do, like, I thought it would be, like, wouldn't I like do 1/3 U to the -3, or is that
That's derivative.
derivative supposed to be
Yeah, that's that derivative. Gotta add one to the next.
add on and apply it?
It's like U squared, right? U squared is U cubed over 3.
So for when I'm using this formula, is this gonna always be the B value?
That's always gonna be your A value.
Okay, and then
And
that's.
then whatever gets would be.
Okay.
And then like, yeah, you're always gonna be doing the, this formula,
Yes.
unless it's, but it's,
Unless definitions given.
unless the graph is like.
Unless.
Let's find this. So.
If the graph is
Yeah, well,
F
if it,
instead of F
no,
prime.
it won't, it won't. It'll always be, it's also a derivative. Unless it's given to you like that, then you plug in, they're official.
Okay, but,
But chances are.
It's like
most of the time you test.
Yes.
It's like 20 points. Now.
Yeah, I should quickly show you the parts, but doesn't do it. These are the two sheets.
I'll see on the test paper. I'll do my math.
I just use. Yes. Oh, yeah.
Thank you.
Look at,
This-
Right, so that's a semicircle, right? So a semicircle, well, I know circle tiles. Semicircle is 1/2 tiles. Just like negative, so 1/2. It's like square. And the radius is B. Yeah, exactly. Or you just do, semicircle, which is, radius of U is on here. So it's.
Nice.
So the whole semicircle is 2 pi. If I split that up, I get pi.
I got that one.
Yeah. Or you can do that. It's up to you.
Same thing out here.
Oh, sorry.
Same thing as it. Yeah.
There's like thunder.
We want something at the same time, so decreasing is the rating.
It was.
It does now, it's positive slope. There's any place where there's a positive slope below the x-axis.
Dude, but you couldn't keep up like these. I
lined it up.
I figured it out, but oh my god, that was you saw that. I know. Next one. Yeah, this is I get 100 right grades. That's funny. That's the last one.
I lined it up so that, all the numbers are in line. So I'm looking for something that has a negative slope and collective rate at the same time, so. That's what I did.
Still in that.
So,
I give up from like, yeah, I'll get it.
It's like your age price, don't look at the.
It's fine. Dude, it's been going on since that base.
phone is.
No, right, like, that's his finals.
What? That's 7%.
Oh, 550 test. Yes. It's highest to max.
And teach
The one, two, I think.
Mr. Yang, so like half the points from this are from homework, right?
Sorry.
Half the points of this test are from.
Right, right. 25 points is from packet 1, 25 points from packet 2. So once we finish packet 2, I can combine those points. That'll be 50 points and this is 50 points.
Oh, yeah.
I thought like I'm putting it in the grade book, while you guys take it. So I did that. Really okay. They're in this one.
Yeah.
Wait, I said, oh, I'm right.
Yes, thank you. I didn't like. So second theorem says the second theorem. So here on the board here, second theorem, we gotta build the derivative first, right? So this is my. I gotta go through my process. Plug into the derivative. Give X. I don't know, it's insertions of functions, so there's 3x.
Oh, just third other line.
Times 2 prime.
It's like, okay, that's.
That's why P plus is like it's 3. Yeah, let's get 80 on it. So these are. I don't know. You eventually need all your book bags up in the front.
Slide with. Wait,
Calculator. Use your calculators today. Just have to show all your work. See. Very much. Today is Tuesday, the 25th.